Hello, we're Team POCAS from Northwestern University, and in the past 6 months, we've advanced an adaptable and open source platform for point-of-care diagnostics. Our solution is POCAS TB, a point-of-care automated stainer for tuberculosis diagnostics. This is an effort in collaboration with technicians and researchers in Mali at the University of Bamako to support the current sputum smear diagnostic pipeline and adapt a point-of-care system for high-throughput diagnostics.
So why are we tackling tuberculosis? Well, a lot of people think that tuberculosis is a problem of the past, but it's actually not as far removed from us as we believe. In 2020 alone, more than 1.5 million people died from tuberculosis. Additionally, there have been an estimated 66 million lives saved in the last 20 years due to diagnostics and treatment. Advancements in nucleic acid amplification systems like EXPERT and other diagnostic systems have revolutionized testing for tuberculosis, especially in point-of-care rural community settings.
The acid-fast microscopy method has a lower sensitivity and specificity than the gene expert system, but it is also significantly less expensive and more commonly used for initial diagnostics for the most infectious patients and for testing the disease progression through treatment.
This smear test, traditionally done by hand, is cumbersome, prone to inconsistencies, and overall time-consuming. We aim to address this by automating the procedure to increase sample throughput and remove technician variability. We estimate that with POCAS, the current production rate of 50 sputum smears per day can be increased to 50 every 2 hours. POCAS is pretty simple to use with the TB Oromine stain. Once the technician has made fresh sputum samples, they insert it into the slide rack, assemble the slide carrier, dock it onto POCAS, and press start.
The most astounding aspect of POCAS is that at its core it is a standard 3D printer. Our firmware modifications and mechanical adjustments enable it to reproduce the acid-fast procedure. This gives POCAS a manufacturing and infrastructure advantage that more proprietary systems lack, as the components are readily available through the 3D printer market. As a result, this lightweight, reliable, and high-throughput diagnostic instrument costs under $600 to develop and will cost less than $250 to reproduce.
We've applied to multiple grants that we will use for the refinement of the POCAS TB so that we can create a carrying enclosure and so we can create a more interactive user display. This funding will go towards establishing performance testing programs so that we can bring the POCAS TB to Mali and test it with our diagnostic technicians on the ground.
Lastly, from Northwestern University, we say thank you, and we hope that you support POCAS in the Rice360 design competition.